Hi, this is Miss Park. This is continuation of rational expressions. Today we're going to be adding and subtracting. So just like with the other lesson on rational expressions, our operations with these things is very similar to what we do with fractions. A long time ago when we didn't have variables in the fraction. So when we add and subtract fractions, we write both fractions. Let's say, for example, we're adding, we'll write both fractions over a common denominator. So let's say if I wanted 3/4 plus 1/6, I would find the lowest common denominator for these two, and that would be 12. So I would write each fraction as something over 12. So 3/4 would be 9 over 12 because I've been multiplying 4 by 3 to get to 12. So I must multiply 3 by 3 to get to 9. How do I get 6 to be over 12? So I would have to multiply the 6 by 12 by 2, which means I have to do the same thing for the numerator. So that's 2 over 12. And then once the denominators are equal, now I can add the numerators and write it over the same denominator. Okay, so now these whole concept of equivalent fractions, 3/4 and 9/12, we're going to do the same thing but with variables. So for example, 3 over 4x, if I want to write that as over 12xy, I would have to multiply the denominator by 3y. I'm just not going to write the times because it looks like x. So I'm just going to multiply that by 3y. This also has to be multiplied by 3y. So on top I will get 9y. Okay, in b, x minus 4, if I want the denominator to be 3 times x minus 4, then I got to multiply the denominator by 3, which means the top is also times 3 to be equivalent. So now that's 21. Okay. Oh, here we go. This is one from the previous lesson. 3 minus x and x minus 3. What do I have to multiply 3 minus x by to get x minus 3? Remember 10 minus 3 and 3 minus 10. When you have a difference and you reverse the digits, reverse the numbers, then you're going to get -1 times each other. So this is times -1, and this is times -1, so I'm going to get -5. Let me just show you again. -1 times 3 minus x is equal to -3 plus x, which is the same as x minus 3. So they're -1 times each other. Last one here, last line, x plus 4 times x minus 2, so I will have to multiply this denominator by x minus 2. Well, then same thing for the numerator. So then my numerator will become 2y times x minus 2. And in the last one, my denominator is going to be multiplied by x and by x minus 2. So same thing with the numerator. So that's going to be my 5 times x minus 2. And you can see that if you were to reduce this fraction on the right, you would get the fraction on the left. Okay, so same thing. And that's how you find the common denominators. So let's do this one. Let's look at the question. Question A, do we see any restrictions? There are no restrictions because there are no variables in the denominator. So I don't need to write restrictions just yet. But I can find a lowest common denominator for 3 and 7, and that's 21. So to go from 3 to 21, I have to do times 7. So I will do the same thing to the numerator. To go from 7 to 21, I have to do times 3. So same thing to the numerator. And now I have the same denominator, so I can just add numerators. And I have no restrictions. So that's the end. Okay, next question. Oh, next question, I can see there are restrictions immediately. So let me write it. So x cannot equal 0, because that will make the fractions undefined. And now I need a lowest common denominator. So let's see what my lowest common denominator will be. Between the 2 and the 5, I'm going to have 10. And I must have an x in the denominator so that the first fraction can be written. But the second fraction also needs x, but I already have one. I don't need I don't need a different x. I already have the same x. So now common denominator would be 10x. The first fraction I'm going to have to multiply the 3 by 5. The second fraction I'll have to multiply the 7 by 2. Okay, and now I have the same denominator, so I can add up the numerators, write it over the denominator, and I'm done. So the last thing is to restate the restrictions. So You're always going to state the restrictions as soon as you see them. Then you can do the work, and then you have to restate them with your final answer. Okay, let's do the next one. Common denominator, so there's no restrictions here. I have no variables in the denominator. So that's going to be a 12. So this is going to be 3 times 2x minus 3. This one's going to be also over 12. So the numerator will be 4 times 6x minus 1. Still no restrictions. But now I have an expression that's over 12. So I can multiply it out. So I got 6x minus 9 plus 24x minus 4. And that is 30x minus 13 over 12. Final answer. No restrictions. Next one. Oh, here's the 3 minus x and the x minus 3. What will my common denominator be? Remember, these are not different. They're actually related because they are -1 times each other. So I can pick either one of them to be the common denominator. In the first fraction, to get from 3 minus x to x minus 3, I have to multiply by -1. So I'll multiply the numerator by -1. In the second fraction, it's already over x minus 3, so I can just leave it as is. Okay. Now what I didn't do is I should have noticed there's a restriction, and I can see it right from the beginning. So before I even did anything to try to common denominator or simplify or anything like that, I must look for the restriction. So it's easy to forget. I've done that now a couple times, but try to remember right away. So I can see x does not equal to 3 here for both fractions. Anyway, now when I add them up, I get this, and I think that's it. So I can just restate the restriction at the end. Actually, had I picked the common denominator to be 3 minus x, my final answer would have been +1 over 3 minus x. Okay, so both of these final answers would have been fine. Okay, last one on this page. Common denominator is 15. This is a really good one. Okay, now here, when I'm going to write this over 15, I have to be very, very careful. This is 3 times 5x minus 2 minus 5 times 2x plus 7. The reason I'm writing it like this, because that minus has to be distributed now to everything in the second fraction. It's subtracting the entire second fraction. So you have to be very careful with it, because a common mistake is to just say minus 10x and then plus 35, but it's not, because it's minus 10x and also minus the 35. Okay, so that minus must be distributed to everything. So here, now I can expand this, 15x minus 6 minus 10x, and it's minus 35. I will put a star and write distribute the minus. Common error. Okay, over 15, and then this is going to be 5x minus 41 over 15, and there were never any restrictions here because there's no variables. Okay, so that is adding and subtracting. What if the expressions are a little bit more interesting? So we'll just do these and then we'll be done. Okay, so first one here, I already see a restriction, a cannot equal to 0, so we'll write that right away. And now we'll try to find a common denominator. So we have 3 fractions that we want to combine. I see we have a 5, a 2, and a 1, so the common denominator has to have a 10. And now I need some power of a that these will all divide into. So I'm going to need to take the largest power of a so that they will all fit into it. Okay, so now to go from 5a to 10a cubed, I'm going to have to multiply by 2a squared. So my numerator is going to be multiplied by 2a squared. So I'll have 4 times 2a squared. And the second one, I have to go from 2a squared to 10a cubed. So that's a multiplication by 5a. So my numerator is going to be times 5a. So 3 times 5a. My last one is going from a cubed to 10a cubed. So it's just multiplication by 10. So I will do that to the numerator too. And my final answer is 8a cubed minus 15a plus 10 over 10a cubed. And notice this cannot be simplified further. I cannot reduce this 10 with this 10. The only way you can reduce is if 10 is a factor of every term here. I would have had to factor out a 10 from everything and then reduce by 10s, but I can't because the 8 and the 15 are not divisible by 10. So that's my final answer. I just have to restate the restriction at the end. Okay, let's do this one. So it's hard to see the restrictions right now because I can look at these and notice that they need to be factored. So we'll always factor first before trying to state restrictions. Okay, but I see that now that I factored, I see that this m minus 2's are all are the same in the two fractions. So plus 1. So at this point, I can see my restriction nice and clear. So m does not equal to 2. And now I'll work on the common denominator. So I have 3 fractions to work with. My common denominator must contain a 2 and a 3, so it's going to have a 6 in it. My common denominator must contain this m minus 2, because they both have it. So this will be my common denominator. Now I'll write the numerators. We're going from 2 times m minus 2 to 6 times m minus 2, which means I have to multiply by 3. Here I'm going from 3m minus 2 to 6m minus 2, so I have to multiply this 3 by 2. And this 1 had a 1 as its denominator. Now I want the denominator to be 6 times m minus 2, so I must multiply the numerator by 6 times m minus 2. Now let's collect this. I'm going to have 3m minus 6 plus 6 times m minus 2 over 6 times m minus 2. That equals 3m minus 6 plus 6m minus 12 over 6 times m minus 2. This is 9m minus 18 over 6m minus 2. And it looks like I'm done, except if I look very, very closely, I see that the numerator factors. There's a common factor of 9. So I can actually keep going. I should keep going until I can't go anymore. And look, m minus 2 and m minus 2, these will reduce. 9 and 6 will also reduce. And my final answer is 3 over 2. I just got rid of all of the variables. And that's my final answer. And the last thing I need to do is restate the restriction, which is kind of funny because the final answer doesn't even have m's in it. But I'm saying the final answer is 3 over 2 and m can't equal 2. It doesn't make sense, but that's because m refers to the original question, right? So that the original question cannot be undefined. Okay, let's get the C and D. So writing the restriction is easier when you factor first. So I'm going to do all my factoring. Now writing the restrictions easier. So x does not equal to -1 and +3. Notice 6 and 4 will never be 0, so we don't have to worry about them. We only worry about these brackets that have variables. Those brackets can never be 0. Okay, now common denominator. From the 6 and the 4, my lowest common denominator will be 12. I need an x plus 1 for the first fraction. I also need an x minus 3 for the second fraction. So my common denominator will have to include all of them. And so now what do I multiply by numerator by? So this should be multiplied by 2 to go from 6 to 12. and there's my x. I already have x plus 1, so I need to multiply by x minus 3. This one, I need to go from 4 to 12, so there's a 3. There's my 5. I already have x minus 3, so I need x plus 1. Adding them together, I get 2x squared minus 6x plus 15 times x plus 1 over 12 times x plus 1, x minus 3. This is 2x squared minus 6x plus 15x plus 15 over 12 x plus 1, x minus 3. And this is 2x squared plus 9x plus 15 over 12 x plus 1, x minus 3. And really what I should do is try to factor the numerator, because I could get lucky and the numerator will have a factor that reduces with one of the factors that I have in the denominator, but this particular one doesn't seem to factor. So I'm done, and I just restate the restrictions. Okay, and finally, last one. So let's factor again. So remember we said at the beginning of the course how important factoring is? So you can see here, the problem is any mistakes with factoring will make it so that we can't reduce nicely. And then expressions that are meant to simplify stay very, very complicated because they can't be reduced. So factoring correctly is key here. All right, now that I have, oops, I wrote x's, these should be y's. Now that I've factored everything, I can see the restrictions clearly. So y cannot equal to, first bracket, -2, -3. Here we have 4 and also -3. And I know they're out of order because -3 is the smallest, but I can fix that in my last line. I can leave it like that for now. Common denominator, I have to have a y plus 2. I have to have a y plus 3. In the second bracket, second fraction, I need a y minus 4, and y plus 3 I already have, so I don't need to add it again. So I need these 3 factors in my denominator. Okay, what goes in the numerator? So first denominator, I need times y minus 4, so I will put 4 times y minus 4. Second denominator, I need to multiply by y plus 2. So I have 5 times y plus 2. All right, and then I can put them all together. Y plus 2, y plus 3, y minus 4. Okay, and I have here 4y minus 16, and here again being so careful with that minus because it's going to need to distribute to both of these terms. So that's 4y minus 16 minus 5y minus 10 over y plus 2, y plus 3, y minus 4. This is an awful lot of writing, but that's the nature of these questions. So this is negative y minus 26 over y plus 2, y plus 3, y minus 4, and this cannot be simplified anymore. So it's done, and I'll just state the restrictions, and this time I'll state them in the correct order. So -3, -3, -2, and 4. Okay, and there you have it, adding and subtracting rational expressions. Thank you for watching.